Good morning, all. In today's class, we are going to discuss about the concept of multiplexer. So, multiplexer is a part of combinational circuit. We know in digital circuit, there are mainly two types of circuits, sequential circuits and as well as combinational circuits. In combinational circuit, the output is purely depend upon the present input. In the case of sequential circuit, the output is depend upon the past output and as well as present input. So multiplexer is a digital circuit that takes multiple input lines and selects one of them to be to the output based on a set of control signals. Okay. The primary function of a multiplexer is to route data from one of the input lines to the output lines. Here we are having selection lines. That is, these lines will determine which input will be connected to the destination or the output. So it's a combinational circuit and that has 2 raised to n input lines and a single output lines. It is having 2 raised to n input lines and a single output line. And simply the multiplexer is a multi-input and single output combinational circuit. The binary information is received from the input lines and is directed to the output line. And we are using this multiplexer in various situations like for signal routing, data transmission, resource sharing, analog to digital conversion, etc. etc. And it is also known as MUX. Okay. So here we are discussing about 2 by 1 multiplexer. 2 by 1 multiplexer means we'll be having two inputs. Okay. Suppose we are having A0 and A1 as the input. We are having two input and one selection line S0 and single output line Y. Okay, that is 2 by 1 means 2 input, 1 output. On the base of the combination of input which are present at the selection line, one of these two inputs will be connected to the output. By using the figure, it will be easy. So, this is the image of a 4 by 1 multiplexer. Here we are having 4 by 1 means 4 inputs. We are having 4 inputs and 1 output. And we are having two selection lines S1 and S0. If it is a 2 by 1 multiplexer, we'll be having 2 input and 1 output. And we are having 1 selection lines. Okay. So in the case of 4 by 1 multiplexer, we are having the inputs I0, I1, I2 and I3 and our selection lines are S1 and S0 and the output is Y. So in this, for the two input combination, we know the total possible combination will be 2 raised to 2, that is 4. So first, we based on the input on the selection lines, it will be deciding or based on the values in the selections line, it will be deciding which input will be going here. Okay, when I3 will be going here, when I2 will be going here, when I1 will be going here, everything is determined by the selection lines S1 and S0. So in this figure, okay, so here the inputs are 0, 0. Here, whenever the values of S1 is equal to 0 and S0 equal to 0, at that time, I0 will be going to the output line. Okay, when both the S1 and S0 are 0, 0, that time I0 will be going to the destination or it will be multiplexed and it will be the value in the I0 will be going through this multiplexer. Okay, and if the value is changed to I0 to I1, if it is changed to S1 is equal to 0 and S0 as 1, at that time will be going I1. So next I1 will be going. Whenever the value it is S1 is equal to 0 and S0 is equal to 1. When the value of selection lines are 1, 0, that is S1 is equal to 1 and S0 is equal to 0, then the value in this input line I2 will be going to this y. At that time, I2 will be going to y. And when both the inputs are 1, 1, that is S1 is equal to 1 and SR is equal to 1, at that time, the value in the I3 will be going to this multiplexer. That is, y will be having the value I3 whenever the input combination of selection lines are 1, 1. That is, when it is 0, 0, it will be I0, 0, 1, I1 will be going 1, 0 of the selection line value 1, 0, I2 will be going, and for 1, 1, I3 will be going. Okay, so this is how, based on the selection lines, it will be transferring the input lines. So from the truth table, we can write the Boolean function, that is, so for S0 equal to 0 and S1 is equal to 0, at that time I0 will be going. That is, S1 is equal to 0, S0 is equal to 0, S1 dash and S0 dash and I0 is having the value as 1. So I0. After that, whenever the I value of S1 is equal to 0, that is S1 dash. 0 means S1 dash. And whenever the value of S0 is equal to 1, I1 will be going. Okay, this particular case. After that, whenever the value of S1 is equal to 1, that is S1 itself, and whenever the value of S0 is equal to 0, that is S0 dash I2. Okay, then the next case for the Boolean function for I3. That is, whenever both the S1 and S3 is having the value 1, then only I3 is passing through this multiplexer. So from this, we got the Boolean function as y is equal to S1 dash S0 dash I0 plus S1 dash S0 I1 plus S1 S0 dash I2 plus S1 S0 and I3. Okay, this is how we can create the Boolean function. From this, we can develop the circuit diagram. That is, for this all the plus case, we need OR gate, correct? For this, we need OR gate, and also for all this combination, that is for S1 dash and S0 dash and I0. In order to get this particular function, we need AND gate. So we need both AND gate, OR gate. Along with that, some complement is there. It is negation is there. So we need NOT gate also. So we need NOT gate. Then we need OR gate, and as well as we need AND gate. So by using these three basic gates, we can create a circuit diagram for this particular multiplexer. Correct. So what and all are the inputs for creating this particular circuit diagram? So we need S1 we need and S0 we need. Then what else we need? I0 needed, I1 needed, I2 needed, and I3 needed. All together, then only we'll be getting the equation for this particular Boolean function. Okay, so AND, OR, and NOT. See, these are the Boolean function, and this is our truth table. And from this, we are creating the circuit diagram. Just look at the circuit diagram. Okay. So what are the inputs? S1 is one input, S0 is another input. Then we are having I3, I2, I1 and I0. Consider this first case. S10, S1 dash, S0 dash and I0. So for S1 dash, this input we have to pass to this NOT gate, correct? So it is passed to the NOT gate, and here it is. Now after that, we need S0 dash, correct? So S0 is here, and again it is passed through a NOT gate. Then it will be getting S0 dash. That's also passed through an AND gate. After that, the third input I0. That's also passed through this particular AND gate. And here we will be getting this equation for I0. Similarly, for each and every Boolean function, for this particular function, we'll be getting similar kind of circuit. That is, for S0, S1 is connecting here, S0 is connected here and I3 is connected here. That is 1, 1, I3, which is the combination of this one. For this particular case, we'll be getting here. So this function will be getting here, and then next I1 will be getting here, and then I2 will be getting here, and I3 will be, this I3 will be getting here. And all these results are passed through a NOR gate. Then we will be getting the altogether Boolean function, the final Boolean function for the multiplexer. So for the multiplexer, it's also known as a mux, and it will be a 2 to 1 or 4 to 1. Multiple inputs will be there. 2 raised to n input will be there, and a single output will be there. And the number of selection lines determines the what type of or which type of input or which input should be passed to this particular multiplexer. Okay, that's all for this particular case. And thank you.